Hello there, welcome back. What we're going to look at in this video is the extreme value theorem, meaning that if you have a continuous function on a closed interval, there is a guaranteed absolute maximum value, or as we sometimes call global maximum value, and a global minimum value. And looking at our function here, our function is definitely continuous. There are no breaks in the graph, so therefore we can use the theorem. So the way mins and maxes work, we definitely have to check the endpoints. So we have x equals 16 and x equals 64 as candidates for where maximum or minimum could occur. But we also need to check the inside of the interval by finding the critical number. And those are values, remember, where the derivative is either 0 or undefined. And more importantly, those are values of x where we could see a minimum or a maximum. So it comes down to taking the derivative, setting it equal to 0, finding any critical numbers that are on the interval, and then comparing those values against the ones at the endpoints. So I am going to start by making a table, since we are going to be substituting several values of x. And we already know that 16 is going to get substituted, and we already know that 64 is going to get substituted. So let's see what else we can find here. So I'm going to first write the function in a form that's easier to find the derivative, and that is using exponents instead of radical symbols. And then the derivative is, well, let's see, 1/2 times 10 is 5, x to the negative 1/2 minus 1. And just looking at that, we have x to a negative power, which means 1 over x to a positive power. I'm going to write it that way so we can more clearly see what's happening. We see that this is undefined when x equals 0. But that value is of no concern to us because that's outside of the interval that we're interested in. So we can ignore the fact that this is not defined when x equals 0. So I'm going to focus on where the derivative is equal to 0. So then I'm going to add 1 to both sides. And I'm going to multiply both sides by x to the 1/2 power. Now remember, x to the 1/2 is really the square root. So if it helps you to solve that, convert that to a square root, and then I'm going to square both sides, and we're going to get 25 equals x. And that, remember, is what we call a critical number. More importantly, it's inside of our interval, so that means there definitely could be a min or a max happening when x equals 25. So we'll substitute that there, or we'll place that there. Now we're ready to substitute all of our values. We're going to plug in 16, 64, and 25 and see what the biggest and smallest values of f are. So plugging in 16, we get 10 square root of 16 minus 16. 10 times 4 is 40, minus 16 is 24. If we substitute 64, we have 10 root 64 minus 64. 10 times 8 is 80, minus 64 is 16. And finally, substituting 25, 10 root 25 minus 25. Root 25 is 5, times 10 is 50, minus 25 is 25. So look at that. We have our maximum value here and our minimum value here. So that means that the global minimum value is 16, which occurs when x equals 64. So we could say at the point 64, 16. And the global maximum value is 25, which occurs at the point 25, 25. And there we have the extreme value theorem.